The question asks, a gas expands in volume from 26.7 milliliters to 89.3 milliliters at constant temperature. Calculate the work in joules if the gas expands A, against a vacuum, which is known to have a pressure of 0 atmospheres, and B, against a constant pressure of 1.5 atmospheres. Let's look at what we know if we need to calculate work. We know the equation. Work equals negative pressure times the change in volume. So if we look at our conditions under question A, against a vacuum, we would say work would be equal to negative a vacuum, pressure would be 0 atmospheres, times our change in volume. At this point, we don't need to continue on any further because we have 0 pressure. So if the gas is allowed to expand under no pressure, there is no work going to be produced, and you will have a work value of 0. Our second question now has a constant pressure that we're going to be working. So we set up the exact same equation. We identify our pressure. We identify the constant pressure of 1.5 atmospheres. Plug that in. So we have negative 1.5 atmospheres times our change in volume. Remember, the change in is always final minus initial. So in this case, we're expanding from 26.7 milliliters, our initial volume, to 89.3 milliliters, our final volume. So when we look at that, 89.3 milliliters minus 26.7 milliliters. Now it's a simple plug everything in and determine the final value here. If we were to calculate this out, we are going to get a negative value of 94 milliliters per atmosphere. Now, if we want to calculate, and it said initially that you wanted to do all of this relative to joules. We need to know that, to make the relation, that 1 joule is equal to 1, oops, made that mistake. Let's actually do it backwards. Let's do it this way, where 1 atmosphere liter, or liter atmosphere, is equal to 101.3 joules. We now can draw a connection between the two and use a conversion factor. The only issue is we have milliliters. So let's change that negative 94 milliliters into liters. So negative 94 milliliter atmospheres. Use our conversion factor to change the milliliters into liters. We know that you have 1,000 milliliters in 1 liter. So now we can divide our number by 1,000, and we would have negative 0.094 liter atmospheres. And finally, we can use our equation, or conversion factor, that there is 1 liter atmosphere equivalent to 101.3 joules, so that we know that the work in joules for allowing this gas to expand against a constant pressure of 1.5 atmospheres is going to be equal to negative 9.5 joules. So we had 2 separate conditions. 1 against the vacuum, which has a pressure of 0, so no work can be done. 1 against a constant pressure of 1.5 atmospheres, and we can determine that there are going to be negative 9.5 joules of work, which means that the system is going to do work on the surroundings, which is true for expansion.